Welcome to the next part of the Hack and Slash tutorial series. In this video, we're going to actually start working on implementing our AIs. So far, we have an AI. Once you walk in, the AI will chase, and then the AI will start to strafe. And I'm not using EQS because using EQS in an actual game is probably bad, because EQS is a very heavy tool. It does require a lot of CPU usage, and so once you have lots of enemies, and in actual games you typically do have lots of enemies, having EQS is going to be probably bad. And so instead we're just going to have the enemy move to a random location based on the area around the player. Now if the player moves too far away, the enemy will stop strafing and start chasing. But once it becomes in range, he'll start to strafe again. The enemy will find a new target and then face the player. So even though I'm going to run behind him, he's going to find a new target place and then he face the player. Run too far, he's gonna chase. And so that's what we have so far. I was hoping to get into more combat, but the video is kind of long already, so I'm gonna tackle combat in the next video. But if you guys want the project files, head over to our Patreon, join me there. Without further ado, let's get started. So welcome back to the next part of the Hack and Slash series. In the last part, we worked on setting up our AI controllers. Well, technically we just added them, but we didn't set up any functionality yet. But what we did do is make this spawner. As you see, there's this big box. If I walk into it, enemies will spawn based on a radius, and they always spawn on the ground. They always spawn facing towards the player when they enter, and so as soon as they enter, we should be able to engage in combat. And so in this video, we actually want to start working on our first AI. And so the first thing we want to do is duplicate our dummy, and the reason why we're duplicating it is because the dummy already has all the hit reaction animations already in it. So we don't have to set those variables again. And we're going to call this melee enemy. Now let's open up our AI controller. Open this up. And I'm going to search for begin play. And we're going to get control pawn. And we're going to cast this to base enemy. And in our base enemy, we're going to need a variable. So let's open up our base enemy. And the variable we're going to need is a behavior tree, just so that we can have different enemies run different behavior trees. So behavior tree, we're going to compile that. Another thing we want to do is inside our class defaults, we want to search for AI controller, and we want to select our custom AI controller, which is BP AI base. And in this variable, or inside the AI controller, we want to get our behavior tree, and then we're going to look for a function called run behavior tree. Run behavior tree, and then our target would be our enemy, I suppose. Well, it'll be an AI controller class, so this would make a reference to self. And then self, we want to get behave Blackboard, and then I want to check if this is valid before we do anything else. So I'm gonna search for a print string off this pen instead, print string, and then we plug this in. So what I'm gonna do is I'm gonna start, and of course we get a false because this dummy AI doesn't have a behavior tree, but for our melee enemy we should. So search for behavior tree, and let's select our only behavior tree, which is BT melee. Let's pull this up here. And inside our spawner, I'm going to select this, and I'm going to select our melee enemy, and I'm going to spawn him once. I'm also going to move this spawner a bit closer. So let's start. Now if we run in, do we get a print string? So if I hit F2, so let's have if I check the log, we should have gotten it, but let's double check. Let's put F9 on here, a breakpoint. Now let's give this a run. So we do get one print. Let's see if we get another. So we don't get another print, which is very weird. See, let's search for AI controller, see. So it is the AI base, which is correct. Okay, control pawn on begin play, and then we run the behavior tree. Let's see if this ever gets called. So it should get called twice when we spawn an enemy. Yep. And then if we run in here, it doesn't get called. Huh, that is super interesting. Maybe because we're no longer in the begin stage phase. So let me delete this and search for on possess. Maybe that might work. And the possessed enemy instead of get controlled pawn. Oh, I think I know why. So inside our base enemy, what we want to do is search for spawn. Not spawn. There should be a settings for possess. It's right here. So auto possess AI when spawned or placed in world. There you go. Now that should do the trick. Okay, we get a false and we get a true. Also, so we do get a Blackboard. So what we're gonna do is we're gonna get our Blackboard. And we're gonna check it's valid. Is valid. If it is valid, we want to promote it to a variable just so we can set it later. Or we can just set it all now. You know what, let's just set it now. So we only need to set one variable, I think, which is set value as actor, if that's still a thing. Nope. So we're gonna have to set as object. And for the target name, we're going to need a variable first. And so if you're new to AIs and you don't know what a Blackboard is, it's simply a list of variables that the behavior tree can use. And because the behavior tree can't use any other variables, only the variables in the Blackboard, we will have to set them somewhere in order for our functionality to work. So let's make a object variable, and they don't call it variables, they call it keys. So I might say variables and I might say keys sometimes. So just a heads up. So we're going to make a object key, and inside the base class we're going to search for actor. And since we call it target, we're going to need to have the same exact name or it won't work. So we're going to promote this to variable and then compile. Sucks target. Let's rename this to target key name. And then our object type, we're going to get player controller or player character. So now if we give this a run, we should have no errors. Okay, now we also want to check if our variable was set, and to do that we open our behavior tree, we play the game, and then we spawn our melee, and then we select it up here if we can. Where's this AI? There he is. But I'm not sure if this AI was set or if this variable was set. So let's see. Let's drag an AI into the field and let's just see from there. So let's go our melee. No matching. Very weird. Because we do have an AI enemy who is... Well, let's do it this way. If that doesn't want to work, we can do it another way. We can do something called get value. It has object. Our key name is going to be our target. And then we're going to check is valid. And then we're just going to print string. This is just basic test to see if we can get a character, because right now our behavior tree isn't working, and I think it's because we don't have anything in here. But even so we get a false. And do we ever get a true? Yeah, so we do get a true here. We do have an actor that does set the player, so we're good there. Let's see, on possess. Let's see there. We can delete that one. Now inside the behavior tree, let's start off with a selector. And so there are 3 different types of nodes that you can add. A sequence, which basically plays all of its tasks in order. If one of them fails, this entire node fails. You have a selector, which attempts to play will attempt to play only one of its child actors. So if we make another selector, sequence, whatever, it will only attempt to play one of them. And if one of them plays successfully, then this will return successfully. So if this one plays, this will never play. If this plays or this does not play, then this will play. But know that if all of them fail, then this fails. We have a simple parallel. I won't be using that, but essentially you have 2 tasks that can run and one of them takes higher priority. But we won't be using that, as we'll control most of it with selectors and sequence. So we're going to start off with selector because we're going to have different states, and states only one of them need to be successful, not all of them do. And so we have a selector, and then we could do a sequence here. And what we're gonna do in this sequence is chase the player. Now what I want to do first is see if we added a couple of nodes, if we can select. So we don't have anything yet. If we walk in, there we go. So we do have one. Okay. So we did have to have a node in order for it to work. So as you can see, we have our first enemy in the world, and as you can see, we have our player character set as the target. Perfect. So here we can also use decorators. What decorators are, it's our conditions. And so in this case, if we want to chase the player, first we want to know if the target is valid. So we select our target key and make sure it is set. So if it is set, we can play whatever functionality is in here. If it is not set, then this sequence is false and will never play. So basically it's kind of like behavior trees are like big long if statements to determine what you can and cannot do, and it's quite useful. Service is another one, and what service does is it checks, or it's like it's something that runs almost instantaneously. So every once in a while it'll run, and it will do some checks, it will perform actions, set variables and whatnot. I don't think we'll be using services, but we might actually use services now that I think about it. But for now, we'll just get a simple thing rolling, and then we'll move on to services if we need to. Now to perform a task, or perform something like chase, attack, we call them tasks in the behavior tree. And so a very simple one is a move to, basically move to some location or actor. In this case, if the target's set, we want to chase the target, so we want to move to target. And then acceptance radius is how far away from that point in order for this task to be completed. And I can just set this to 10. Now it should work, hypothetically. Yeah, so, but the only issue is that we don't have any motion. It's because the AI just moves, but there's no actual motion. Now I think to fix that, we need to use, it has something to do with our controller. So use control, desired rotation, I think, maybe. Let's see, maybe that might be it. Nope, so that's definitely not it. Move to, there's definitely something very tricky here. It's been a long while since I've done this. So I think the issue is because we're moving the controller instead. So what I want to do is, instead of trying to run the behavior tree on the task, I want to see if I can run it. Well, because this one does need an AI controller, and this is also an AI controller, I assume. Could be an actor, but we run the behavior tree on the controller, so very interesting. It's been a long while since I've done this, so bear with me while I try to figure this out. So I don't think I'm able to get this thing to work. So another thing I want to try instead is make our own custom move to. Let's just try that. So let's select this new task. Let's make a new folder called task. And inside this folder, this would be called BTT task called move to. And in here, we want to get an execute AI. Event receive execute AI. It's kind of like our begin play. And what we do is a AI move to. Our pawn would be controlled character, or controlled pawn. There it is. And then destination or target. We want to get a variable and we want to call it target key, because we only want to move towards the target. And to do that, we need to get a Blackboard key selector. We want to expose this. Now this is a Blackboard key selector and this is an actor. So we need to get value as actor, and then we plug this in. And then acceptance radius, we can also promote that to a variable and expose it. And then once we finish, we want to finish execute. Now this is very important. We want it to true. So if it finishes or not, because if it never calls a finish execute, then it will never actually exit the task. On fail, we want to finish and execute as well, but we want to make sure it doesn't succeed. So here, let's call our new move to. So BTT move to. Let's select our target and then an accepted radius of 5. Sure. Let's give this a run. So we're still getting that weird sliding. Do we have an actual, hold on. is our mesh using, let's open up our base, let's open full blueprint, let's open our animation. So using our player animation locomotion, let's try APP Manny. See if that works, helps. Nope. So he just slides towards us. That's super weird. Let's check our variables here. Use controller, desired rotation, orient rotation to movement. Maybe that's the reason why. Nope. See another. We're gonna have to mess with a bit of settings here until we find something that works. Typically it usually works on my end. Nav mesh, acceleration fast. Let's try that. Okay, so now it's working. Okay, so I think it's because we have to use control rotation. So we don't have to orient, so we cannot orient to movement. We have to use control rotation or control movement. Yeah, so we do. Okay, so it's a lot better now, but it's a bit of snappiness to the rotations. Kind of want to use this though. Control rotation, but it's alright. It works, and that's good enough for me. So there's a bit of snappiness when the character rotates. So let's change the rotation speed to like maybe 200. So we can probably ease down the little snappiness. And this, let's see, stop on overlap, destination. Yeah, okay, yeah, that should be good. Another thing I want to try is if we can still use the old move too, because that would be cool if we can. Okay, yeah, so we can use the other move too. So let's use the old move too. This one you can keep, but the reason why I want to use the old move too is because we have this. And so what this basically does is it will update the location, the move to location based on this distance. So if it moves like 10 Unreal units away from its last location, then it will update the new location for the AI to move towards. It's a lot better actually. So see, we have an AI that chases us. We'll need it to strafe and we need it to attack. So let's tackle strafing before anything else. So here in the Blackboard, let's make a float and call it distance. Call it strafe distance. Distance. And what this value will be, we will have to set this in a moment. So let's make our first service. So what our first service is going to do is it's going to update some of our variables, and it's going to check whether or not we should or shouldn't be in certain states. So let's make a new service here, and let's call it service. I'm going to call it BT service update behavior. Let's open it up. First things first, we want to get our begin play. Should be called event on received, and then we also want a tick. So there should be a, yep, there is tick AI. So what we want to do is on a control pawn, we want to cast to VP base enemy. If it is true, then we want to create a variable and call this base enemy owner. And we might want the controller as well, so let's just, actually, should we? I think we should be fine in that regard. So let's ignore that. In the tick, we want to make sure our base owner is valid. We might need some functionality from it. I don't know if we do, but we might as well get a reference just in case. Now what we want to do is start doing some checks. So what we're going to do is make two Blackboard. So we're going to do, this one's going to be strafe distance. Distance key. It's going to be our Blackboard key selector. Let's duplicate this, and we want another target key. So like I said, these are just Blackboards. We need to get the values from them. So we just showed you how to set values. Now let me show you to get them. We get float. And know that if you try to get a value that the key does not support, you're not going to get a value at all. And so since this is a strafe key, we want to get the float, and what we want to do is get a distance. So what we're gonna do is get distance to. Distance between. So let's grab a base enemy called get distance to. Distance to. There you go. And then our other actor would be our target. I'm gonna get value as actor. And then we want to plug that in, and we want to make sure that if we are less than or equal to the strafe distance, then we should start strafing instead of chasing. So if we are less than or equal to the strafe distance, then we should strafe. Now let's set up our state machine for our enemies. Now we do have a regular state machine that we use for enemy, but we're gonna make another enum, and this one's gonna be specific for our behavior tree. So we're gonna call it e_behavior state. There are gonna be a couple here, so we're gonna have a none, and then we're gonna have a strafe. We have a chase. We have an attack, we have it disabled, and then we have it dead. Now what we want to do is inside our Blackboard, we need to make a enum key. We're going to call it states. And in the enum type, we're going to select our enum, which is behavior states. Compile this. Now let's open up our BT service, make another key. It's going to be E. We're going to call it state key. And what we want to do is we're going to grab this and we're going to set value as enum. And the value is going to be a enum, so we're going to do byte to e behavior states. So what we're going to do is enum literal to enum. So there you go. So we're going to do a literal enum, and then we're going to convert that from a enum to byte, because the enum input here for setting enums is a byte, but this will allow us to select which one we want. So if we are in range for strafing, we should strafe. Excuse me. And if we are not, then we want to grab our state key and we want to set it to we don't want to strafe, we want to set it to something else, and that would be chase. So if we are in range for strafing, we strafe. If we're not, we chase. So now let's head back over to our behavior tree, and in our selector we can right click our selector at the very top and add a service. Let's select our own servers, and then let's set up our keys. So our strafe distance, target, and then our state. Now not only should we check to chase, not only should we check if we are in range or if our target is valid, we should first check if our states is equal to chase. And the same could be said for strafing. Now we actually need to set the strafe amount. So let's do that in the AI controller. Now right here, we could pull off. Actually, we could make a function. So let's make a function, call it set Blackboard keys. Board keys. And let's copy this over. Let's copy all of it over actually. Let's cut it. This one, let's make it itself. Let's open this function and paste it all in here. What we need to do is another set value as float. And what this will do is determine our strafe distance. Now if you'd like different strafe distances, like I said, make multiple controllers and then apply those controllers to different enemies. But since I'm gonna keep all the controls the same, it's pretty much the same thing. So let's just call this distance, strafe distance. Backward key name, let's make a variable, call it strafe distance key name, and then let's make sure we copy it, and then settle back over to our controller, compile, click it on here, paste it in, boom. Now let's actually set a value for our strafe distance. I'm gonna say if we are 300 units away from the player, we should start strafing. That's gonna probably need testing a little bit. So here I'm gonna actually call it wait, just so we can see it working. Let's save everything and compile, and let's see it run. So we are not chasing. Hold on. Is this even working? Okay, let's walk in. Yeah, so we are setting this state to strafe. If we check our melee, our target is... We don't have a target. Oh, that's right, because we never call that function. So in our event graph, let's set Blackboard variables, set Blackboard keys. Now that should work. So now we have an enemy who's waiting currently because, yep, now it's chasing, now it's waiting because it's trying to strafe now. Now as you can see, even though we set the variable to strafe at 300, he's still walking very close. And now what we can do there is, in this key, there's something called observer aborts, and basically what this does is it checks whether or not if we should leave this current functionality if this value gets changed. And what we want to do is we do want to stop all functionality and then move on to the next one if we are no longer in this chase state, and the same could be said for the strafe. So we want to abort itself if we are no longer strafing and do whatever other functionality we should be doing. So now we chase, and now if I move away, he'll start chasing again, and he doesn't wait for that full timer, that full wait time to elapse. And see 300, as you can see, 300 units. Now we could also up the distance on that strafe distance. We could probably bump it up to like 800 maybe. Yep, so 800 is quite far. So maybe bump that down to 500. And then for our move to, let's set something more reasonable, maybe 250. Nope, so that's 500 almost. Yeah. Now we can also lower this time. So basically this only gets called every 0.4 to 0.6 seconds. We can lower this a little bit. 0.4, 0.4, 0.1. So 0.2 to 0.4 seconds. Just so that, and by lowering the amount of times this get called, by increasing the amount of times this get called, you'll get more accurate numbers. So every time the amount of when he stops is more accurate. But know that when you have a lot of AIs, they're gonna start spamming this. It's kind of like a tick. So it's best to try to minimize it the best you can, but also put it in a value where you get the functionalities to work perfectly. Now to get strafing to work, I'm not going to use EQS, and the reason for that is because EQS is very heavy on your hardware, and for action games specifically, you're going to have lots of enemies, and if every enemy is going to run EQS, you're going to lag really hard. So what we're going to do instead is we're going to do a basic, super simple, it's not even I wouldn't even consider it good coding practice, but it's a very simple way of doing it. It's what I did for Project Bloodbounder, and I kind of want to show it. So we're just call it strafe. So let's make a new task and call it strafe. Let's open it up, and on execute, we're going to call event on execute. So event execute AI. Execute AI. What we're going to do is we're going to set a something called like add movement input. There you go. So yeah, add movement input. I know, sounds bad. It's what I use for Project Bloodbounder, and it's better than using EQS for an action game if you're running. But I mean, to be fair, there's another one called get random navigatable point, get random location navigatable radius. That's the one we did to spawn the AIs. You could use that too. But what I'm more worried about with this is where if the enemy strafe too close to the player. but let's use this actually. I feel like we could add a bit of functionality later to check if the player or if the enemy is too close to the enemy and should back off. So if the enemy is too close to the player, he should back off if he's not attacking. So origin, you want to get the target. So target, call it target key. Call it Blackboard key selector, and let's get as actor. And then we're gonna get active location. And now radius, we can actually promote that to a variable. And then when we find a location, we want to AI move to. So AI move to. The pawn will be control pawn, random location, boom. Acceptance radius, I'm gonna set that to 10, but let's promote that to variable as well. Make sure it's exposed. On success, want to finish execute. And then want to tick success. And then on failed, we want to untick success. So I think this is a better approach. But we will have to add additional functionality later. So let's call strafe. Set our target key, our radius. Let's say 500. Now because we're setting the strafe super early, we'll have to bump up this number a little bit, just so that our sphere doesn't get drawn. Our navigable sphere does not get drawn to the point where the enemy runs too far, strafes too far away, and then have to re-enter. So let's drop this down to like 400 maybe, accepting radius 10, sure. And then yeah, that should be good. Now let's give this a try and see what it looks like. So he's now starting to strafe a little bit. Now he's running very oddly. So what we also want to do is make a wait node. So after he strafes to a position, he's going to wait for a bit of second. So I'm going to say 1 with an interval of 1. So he either waits for 2.5 seconds or 1.5 seconds before moving to the next point. Actually, let's bump up that number. Say 3 with an interval of 1. Now one thing I also want to do is, if we have a valid character, so let's go to our AI and we're going to do something called set focus. So right here, set focus. And then our new focus point would be get character, get player character. And what this focus does, it will just make the controller focus onto the player. See, waits for about a couple seconds. Now he does spin around like that, and he does run a bit weirdly. I think you could add like strafing animations and it would work really well. Let's actually not do this. And what we want to do instead is make our task do it. So what we're going to do is open our task, make a new task, and call it BTT task set focus. And what we do is execute AI, get our controller, set focus, and then we want to get our target. But let's finish execute real quick. Execute, finish, execute. Make sure we tick success. Make a variable called target key. Make sure it's a Blackboard key selector. Let's get our actor. And let's set it. And then let's make another Blackboard or another task and call it BTT task clear focus. And what this will do is on execute AI, we want to clear the focus, so clear focus, and then we want to finish execute and tick success. Now, so what we want to do is when we finish strafing, we want to set focus, and then once we are finished waiting, we can clear it. Focus. Now, I might actually want to move this later, but for now, let's see how that looks. Yeah, so when he's finished strafing, he faces the character. So what I actually want to do is do that. So Let's see if he does still face the character. So he kind of does. Oh no, wait, hold on. We never set a target. Okay, let's set a target real quick. So let's compile that, open this up, let's set our target. That's probably why. Yep, so he does set it. So he does face the character, player. So now it doesn't look very weird. He faces the character once he's finished strafing to a random location. Okay, yeah, not too bad, not too bad. But yeah, so I feel like this video is getting long enough, and I was hoping I can cover a bit of combat too in this video, but for now we have strafing and we have chasing. So I think that's a good stopping point. In the next video I will actually start working on the attacks and whatnot for the enemy. And with that being said, hope you guys will have a great rest of your day. I'll see you guys in the next one.